from the mobile side. There's another team that's looking after them, but just a brief of what they're doing. So I think yesterday in the opening speech, you saw our Deputy Secretary General for the NBTC talk about the 5G. Yes, True is part of that. He will be acquiring the new bandwidth, the new frequency for the 5G. And we are also part of, he talking about in Chiang Mai, in Khon Kaen, in Bangkok, doing all the trial tests. We are part of that. We've been doing that, and we will continue doing that. And at the end of this year, when we get the frequency, we'll definitely be launching that as well. I'm jumping ahead of my CEO, but I'm very sure that we'll be launching it, not the end of this year, beginning of next year sometime. Okay, the other one is that is big for this year for True is we just acquired the English Premier League content exclusive right to broadcast that in Thailand, both on the cable TV as well as on the digital domain. So True Vision has the right to broadcast that on the TV, and True ID, True Digital is the company that now providing all the content on the IP network. So we provide customer with application so they could be watching the content over the mobile phone, on the computer, and we also this year launched Android box called True ID TV, which the customer could access the same content as what is on the True Vision set-top box at home. They could access this over the IP network. So we're offering all of this, and it's consumed quite a bit of bandwidth as well. And that's part of the reason why we need to go to IPv6 very soon. Okay. So I think everybody in this room know we're running out of IPv6 long time ago, so I'm not going to go through that. I asked somebody to prepare a presentation, and he just stuck this in to make sure that everybody aware. But as Henry was just talking about, the IPv6 this year in our region is growing, and Thailand is also the same thing. We are part of that. I'll talk a little bit more what we're doing, things like that. And again, this presentation, it's kind of everybody know what's going on. We ran out of IP address for True. I think in the next slide I'll be mentioning, but we know that we're running out of IP address. We experiment number of things. We did also, I have to admit, where we purchased a block of IPv4 addresses because our executive worried that we will be running out of IP. So in 2014, we did buy a block of IP address. The other thing that we are concerned is the CGNAT. We're using the CGNAT in our network, and Thailand laws require that we need to keep log of all the customer activity. So we need to have that huge log collection system that will have to maintain this log for the customers. Both CGNAT and log are very expensive for us, and we keep having to expand every year because of the capacity bandwidth that is being consumed. Of course, there are new contents that also require consume more bandwidth and things like that as well. For the external factor, I'm not going to touch on too much. Yes, there are a new trend coming in, but for Thailand, we don't see that a lot. So it's not a good motivation for the customer to move over to IPv6. I'll mention a little bit in the next slide as well. But there are a number of new technology drive. Part of it is IoT. The other part is the 5G for the mobile. But for the online side, I think the most important thing that I'll be talking about is the content delivery. For True, about 60% of our traffic, our customer accessing from the CDN, okay? And with that CDN, we see an opportunity to reduce the requirement for the CGNAT. Okay, so I'll be talking a little bit more about that. Sorry. It's not moving. Okay, thank you. So let me talk about the journey for True Internet. In 2012, we start offering IPVs, a dual stack, both V4 and V6 for corporate customer. Yes, we did it a while back. 2012 was the first time that we're doing that. And then every year since then, we've been having seminars and events to promote IPv6 for corporate customers. But sadly is, I have talked in many years that I talk with customers, most of them came back and say, it's an ISP issue. They don't care as long as they could access internet. V4, V6 doesn't matter to them. And it's been a struggle trying to convince them. A number of them are testing and trialing, but not moving any further than that. But there are a number of universities that deploying IPv6 in Thailand, and that's about the bulk of most corporate customers that we have. But 2013, we recognized that we need to have network to be ready to support IPv6, so we've done all of that and we did the audit 2013. 2014, that's a key that I mentioned, that we have to buy additional IP address. That's one of the key, but we also 2014, we offer dual stack to every corporate customers that we have, not only the new one that's signing up, but existing as well in 2014. But as I mentioned, the take-up rate is very little right now with the V6. Then from there, there's not a lot of the activity just trying to push our corporate customer. But 2018, that's where we start talking about broadband customer that we will be offered dual stacks because of the new type of modem that I just mentioned earlier. And then 2019, we're just going to continue pushing this out to our customers. I kind of took it off from our partner, which is Google and Facebook. As yesterday in the keynote speaking, the Deputy Secretary General talked about traffic in Thailand. Yes, Google and Facebook are the two biggest traffic. Somewhere around 60 to 70% are being consumed. Our customers are consuming Google and Facebook content. And about 2-3 years ago, they came and talked to us about, that their CDN are IPv6 ready. So these are some of the graphs that they are telling us that they are seeing increased take-up rate for the IPv6. And then the other thing that we have done a number of tests, and we see that traffic that going through using IPv6, accessing these content, seems to have a better performance throughput than the IPv4. So that's part of the reason why we're pushing to do dual stack for the customer, because it's improved the customer experience. The other one is to reduce the requirement for the CGNAT. So previously, our traffic from our subscriber, all 100% is going through the CGNAT. But today, we have about 30% is going through 67 is going through CGNAT, and the other 33% is going to IPv6, and we bypass CGNAT altogether, and that's helping us reduce our CapEx and OpEx, and that's the justification as to why we need to deploy IPv6 within our network, and management seems to agree to that. Okay, so that's basically, I think I'm running out of time. So that's basically the reason why, justification why we are pushing very hard to deploy IPv6 for the broadband side within True Corporation. These are just summary. We're running out of IPv4. We need to buy IP address. In fact, we are looking to buy additional blocks because of a government project that we will need to deploy school network. But part of that government project, we require to provide them with a individual public IP addresses for each school. So we need to acquire additional IP addresses. Cost saving for us, the capping and OPEC through the IPv6 dual stack through CGN, reduce of the CGN. The new drive is the IoT that we start providing. We don't have enough IP address, some of the demand and the future trend in the future. And that's pretty much my presentation. Is there any question? Thank you. Yes, sorry, Jeff.
I'm sorry, is there a microphone? Oh, sorry, I'll get up.
Yes.
I just have one question, because
yes,
we're doing measurement of countries and indeed service providers and sort of seeing how much V6 is out there. And I'm actually curious about the True network. And there's one question that I'm finding it hard to answer immediately. How many autonomous systems do you have in your network? Is it really about 40?
No, we have four, only four. 7470. That's the first one. The other three, I have to admit, I'm
17552.
That's our customers. Sorry.
Right.
Right. So the reasons why there's 40 for True Corporation, there's only 4. 2 of them for the broadband, 2 of them for the mobile, and the rest are our corporate customers that are sitting behind us that want to have their own AS number.
That is most helpful in interpreting the data. Thank you very
yes,
much.
Sir. Yes, sir.
Good morning, sir.
Good morning.
My name is Karan, and I'm a student of AIT.
Yes.
My question is, when you bypass the CGN net or you say you're using V6, how much of the traffic percentage goes to the IX, the Internet Exchange Point in Bangkok or like wherever?
As I mentioned in this slide, we're seeing about 30% 33% are being bypassed onto the CDN, and the rest is the 67% still going to the gateway or domestic gateway.
So like it's not necessarily like it's going to the IX, right? It can go like wherever it...
Correct. Domestic and peering and some other places, but we measure the traffic that going to the CGNAT. We're seeing that about 33% that are going through that via IPv6. Why? Because as I mentioned, about 60 to 70% of traffic are from Google and Facebook. And that's why we're seeing that saving, because it's routed through Facebook and Google through V6. And we're seeing 33%. Why not 60%? Because some of them you have to go out and get the new content. So we're seeing about 33% right now.
Thank you.
Yes, sir.
Okay, let's thank you for the speaker. Introduce IPv6 deployment in Thailand. Thank you. So because we are running out a little bit behind the schedule, so I need to rush the rest of the speaker. Probably need to run a little bit quicker. So let's introduce the next speaker, Jeff Houston, and he's going to present IPv6 performance. Thank you, Jeff.
Thank you. Where's the clicker? Here's a clicker. Where's the slide?
They're doing now.
They are. We're moving quickly here.
Yes.
Hi, I'm Jeff Houston. I work with APNIC. We do a lot of measurement work. And some of that measurement work is actually looking at how much V6 is deployed, in which countries and in which networks, day by day. But as well as that, we can actually do a little bit more than this. Because when we measure, a lot of the time what we do is we get the same v6 enabled endpoint to talk to our servers in v4 and in v6. And because we now have two separate sessions, we can look inside those sessions and go, who's faster? Does v6 perform better than v4 or not? Now, better is an odd word. And in looking at measurements, you actually need to pin that down. So the first question, is it more reliable? In other words, if I advertise a v6 address for my service and you use v6 to contact me, will it work all the time? So for everyone on v6, can all of you reach me? That's a reliability figure. And the next one, of course, is once we make that connection, does the bits flow faster or slower in v4? So going through it, we get two URLs, one's in v4, one's in v6. It's the same endpoint. So I'm exercising two different protocols between the same two endpoints. I record every single packet I receive from the endpoint using basically a full packet capture using TCP dump. We get around 12 million sample points a day, and because the world v6 rate is around 22% of users, approximately, 22% or 1/5 of those sample points, I see both v4 and v6 measurements at the same time. So, what can I talk about here that will show you what's going on? The first thing that you do once the DNS has done its thing is you start running TCP. This is before TLS or any kind of encryption. There is a standard TCP three-way handshake. If you're running my ad, you'll send me a SYN packet. I will send you back a SYN ACK. You will send me an ACK. Aren't you nice? You have no control over this. It's in the kernel. This is part of the operating system. Very hard to interrupt. That time difference between the first SYN and the closing ACK is as close to one round trip time as I can get. So what I do is I look at these connection attempts. So the first thing, how reliable is it? What if I never get that ACK? So I see your SYN, I reply, I get nothing. Probably because you're blocking v6 close to the endpoint, or you've got a really mangled path in the network. So I'm looking at reliability. And when you think about the way your systems work, you're all running a dual protocol behavior system called happy eyeballs. Now, the way this works is pretty simple. It actually starts v4 and v6 at the same time. You do the DNS, and then you open up the SYN packets, and you've got 50 milliseconds. The first one to complete wins the session. If you don't complete quickly enough, you use the other protocol. Now, if there's a TCP handshake failure, particularly in 6, you'll just go to 4. And the other thing is speed. Why do I measure speed only? Because it's the same TCP protocol. Whether you're using v4 or v6 as a transit, you're going to run the same speed if the paths are the same. The only thing that will change performance between our two endpoints is the latency. And the only reason why the latency will change, more or less, is path difference. So if your v6 routing is not the same as v4, I will see differences in path. Now, there are some other issues with CGNs and so on, but they're nowhere near as big an indicator as a path difference. So round trip time and packet loss probability determines what's going on here. So let's have a look. Across the world, TCP fails in v6 around 1.25%. Now, you might say, well, geez, that's really good. But don't forget, all of these folk completed the ad. So the v4 success rate is 100%. So there's an annoying sort of little niggly bit of people who have v6, who think they're connected in V6, but it doesn't work. And this is a global average. And the thing about averages is that averages lie. So if you look at this data over time, it was really bad in 2017. People weren't doing it right. It's kind of better now, but it's still not brilliant. So what's going on? Lousy filters close to the endpoint. I don't like V6. I'll send anything, but I won't receive. Insight firewalls and filters, or some of you are running some pretty weird transition mechanisms. MAP-E, MAP-T, DNS 6.4, and any other piece of rubbish that your local friendly vendor decided to lump into your network. Do not do this. It's a really bad idea. So here is good. This is actually T-Mobile in America, and the V6 failure rate for that network is in blue. Almost nothing. The country is running at around 0.25%, but for T-Mobile it's 0. Why? Because they're running 464 XLAT. T-Mobile's mobile network is V6. It's 4 that's tunneled over the top. So to reach that endpoint, V6 had to work. So this is why in T-Mobile, the answer is brilliant. V6 is brilliant. That's what I said. Reliance Jio in India, hundreds of millions of users. 464 XLAT. Look at the blue line, it's brilliant. That was a routing stuff up. But underneath it all, this stuff just works brilliantly. Why am I showing you this? Because some people really, really have a problem in their infrastructure. And certainly in Vietnam, things are not as good as they could be. That failure rate of 5.5%, which is kicking around between 6 and 10, really means that for all their effort in deploying V6, a whole bunch of users can't use it. There is something deeply flawed inside some of their networks. And this one is about the worst. The country failure rate on average is around 5%, but AS18403, it's getting worse, not better. So whatever they're doing more of it tomorrow, and it's not a good idea. 1/4 failure rate is just completely unacceptable. You kind of go, if you really like your users, because after all they're paying you money, turn it off and make it better, and then turn it on again. Because what you're doing is you hate your customers, right? Not good. Guatemala. There are some providers in Guatemala doing a shocking job. New Zealand. Anyone from New Zealand? Anyone a Vodafone customer? Lucky you. There's troubles. Colombia, it just jumped recently. Whatever they decided to change, back out. It was a really bad idea, turn it off. It's not working. And then we talked about Vietnam. Oddly enough, just lately it's got worse. It jumped up to 8%. Again, whatever you're doing, it's the wrong thing. Stop doing it. China. China is a big country, and there are a lot of Chinese users on the internet. With India, they're sort of the bulkiest two countries. And they've been doing a lot of work in V6 trying to roll it out. A lot. But with any very large-scale deployment, it's difficult. And their failure rate was at around 4 or 5%. Most recently, it's gone up to 8% failure rate. This is not good. This is really creating a customer experience which you're kind of going, I'll use the internet tomorrow, it's not working today. And my advice to anyone in China who's behind this, go into your phone and turn off V6 and you'll find a much faster experience, because that failure rate is not helping anyone. So this is Thailand. Now, True is just getting started, and there are other providers who've quite a large footprint. So the overall footprint of V6 in Thailand is up around 1/4. It's a really low failure rate. So what can we say about the way they're deploying it? Really low failure rate implies 464 XLAT. So across their mobile networks, I would take a rough guess that they're using 464 XLAT because this stuff is unbelievably good. So underlying this is a decision to run V6 transport in the mobile network and put V4 over the top. That gives really good numbers. The bigger picture, in red, you might as well not use V6 because it's kind of crap. Yes, there is New Zealand. Remind me. Sudan, Pakistan. Now you're testing my geographical knowledge. The Ukraine. Come on, any guesses? Help me here. I think it's Colombia and our friends in Paraguay, I think. Yeah, Paraguay. Is that Guatemala? Whatever. So some of these countries are really bad. And in some ways, it's one or two providers that are just getting it wrong. Why? Why does the United States, Sweden, Thailand, and Korea manage to do this brilliantly, whereas New Zealand, Guatemala, Colombia, and China don't? What's the difference? The IETF did the worst possible job in dual stack transition. The worst possible job. Because instead of standardizing one approach and saying, look, here's an approach, go to your vendor, just do this. We managed to standardize over 30 approaches. Now, as an industry, collectively, we're about as stupid as we get. We might employ bright people, but you know, people in large numbers are really dumb. And when you give 30 choices to the industry, we tend to go, oh my God, and get it wrong. So stateful transition protocols, DNS 4.6, that involve protocol translation, that's why you've got lousy numbers. Because intrinsically, that's really unstable and hard to work perfectly. When you did orchestration of the DNS and network state, DNS 6.4, life got horrible really, really quickly. The endpoints didn't understand what was going on in the middle confused the end, life was absolutely shocking. So some of these transition technologies make you hate your customer. Even if you love them dearly, you still really hate them because their experience is shocking. Don't forget, you're not trying to make dual stack work as the goal. It's not a case of going to dual stack, it's to get to V6. So what you want to do to get there is to exhaust the oxygen in V4. And the way you do that is not by turning off V4. That is way too premature. So anyone who says, let's turn off V4, ignore them. They know not what they say. What makes more sense is when given the choice, make it easier for the endpoint to complete the connection in V6. That's what Happy Eyeballs is all about. So if clients prefer to use V6 whenever it can, then when Google and when Facebook, when Netflix turn on V6, you immediately prefer to use it. You know, happy, reinforcing stuff, it all just works. So this is what Happy Eyeballs was all about. Now, if you only prefer V6 and exhaust that connection before backing off to V4, your customers will have left you. If you're running a standard Linux stack and you say SSH or some standard connection technique, it takes 108 seconds to figure out that's not going to work. Do you know how long 108 seconds is? That was 5. Just imagine how long 108 seconds is. It's enormous. No one's going to wait. Browsers decided that was never going to work. So they adopted a technique that cut that 108 seconds way back down. So in DNS, it runs a 50 millisecond race timer. Now you kind of go, okay, if I get an answer in 4, I'll wait for precisely 50 milliseconds to get an answer in 6. Good idea? Because I'm going to give you the counterexample, aren't I? A lot of network service providers are under imposition to do some kind of filtering of content because the national laws, whatever. And one of the ways of doing this is to use the DNS. So whenever you see a new DNS name, you look it up, find the IP address, and figure out if the IP address is on a blacklist. What protocol, what queue name record, what do you think they'd look up? The A record, because of course the world is V4, isn't it? And so what you find in some cases is that the DNS actually works on a new name only in 4, and then when they figure out it's a good name, they then look up V6. Is it 50 milliseconds? No, it's not. it's over 500. Oops, you've done all this work, you've deployed V6, users can't use it. Over here on the TCP handshake, there's a 250 millisecond delay. So if you're opening up V6, you're going to wait for 250 milliseconds. If that doesn't work, you'll start up V4. So if your paths are broken that badly, that the V6 path is more than a quarter of a second longer than V4, you're going to run V4. So just remember those two timers. What does this mean? If your V6 from India to Singapore goes through the United Kingdom and your V4 goes across the Bay of Bengal, you've just broken the first rule, because that path through the UK is astonishingly long. It's longer by a quarter of a second. So for a while in India, there was no V6 we could see because everyone was preferring to use 4 because routing got stuffed. So when you are routing V4 and V6, try and keep your traffic together. Don't send V6 down the long path and don't ignore it. Try and make sure that when you announce V4 routes, you announce V6 routes. Make sure that your peering and transit is both protocols. Because when you get it wrong, you get India in late 2016. 12.5% of the country at the time was running 6. It's much higher now. But this enormous gap because they were sending the V6 packets to the United Kingdom because, you know, we're professionals. We do this for a living. We're very good at it. And this is the one that I like with more recently, the poor chaps at Vodafone. And this is a DNS problem. Because here, that discrepancy between the folk who can do V6 if you really push, but when given the choice go immediately to V4, is actually all about the DNS basically thinking there is no V6. All my content filtering, all my blacklists are all in V4, aren't they? Wrong. And the result is they've done all the work, but they're not getting the answers. Folk are not using it. Connection failure rate in Vodafone. Like I said, the end results are people don't wait, your machinery doesn't wait. When you add delay, sometimes the machine just goes, not going there. So again, they've done all the work, but they're hating their customer. Things need to change. So this is what I'm saying. Sometimes it's the DNS itself. And sometimes what you're doing works against dual stack. Quad A now answers come out slower than A records from time to time. Because when you look at recursive resolvers, the client asks for both, and sometimes the recursive resolver goes, I happen to like that query for a V4 record, I'll process that one straight away. That V6 one, there's a queue, buddy, back over here. And it just takes some time to resolve. DNS content filters are part of that where they use A queries. And quite frankly, in partial deployment, when there's a lot more V4 than V6, guess what's in your cache? A records. So sometimes A records get delivered straight out of the cache because of all that V4 use, and the poor old V6 users are going, wow, cache mess, let's do the full thing up and down because I haven't got it locally. So the other thing I was looking at was the difference in round trip time. Is V4 or V6 faster or slower? If it's above the line, V4 is faster. If it's below the line, V6 is faster. This is the worldwide average. And on the whole, depressingly, V4 is faster on average, despite what Lee Howard says. And just recently, it rose up a little bit more to over 20 milliseconds. But you know, averages. But you know, averages. China, important market, massive. My servers are in Singapore. So it should just be north-south. North to south. Singapore's just there, somewhere south. Bring out the compass. Why does it take between 50 and 100 milliseconds longer to send a V6 packet than a V4 from somewhere in China to somewhere in Singapore? How wide is the Pacific in milliseconds? Well, about 100 milliseconds. What do we think is going on? The V6 packets are bouncing off the American West Coast, whereas the V4 packets are running north-south. That's why they're getting relatively poor performance on average. You've got to keep your paths together, okay? all you network engineers, stop treating V6 like, the busted, broken child. It's a peer with V4 if you want performance to work. So, 3 humble suggestions, running out of time. Keep your transition mechanism simple. All because you don't understand it doesn't mean it's better. It means nobody understands it. Don't use it. Any kind of stateful transition mechanism, including DNS 4.6, is an invention of some satanic demon. Don't touch it. It's evil. If you can operate in V6 native mode all the way, 4G, 5G, do so. Don't do busted, broken transitions. Tunneling is always bad. And I say this knowing that MPLS is a tunnel. Tunneling is always bad because no matter how you try and do it, there are failure cases that you don't know what's going on and you can't debug quickly and efficiently. Because when you tunnel, you change the packet size. When you change the packet size, sometimes really, really bad things happen because tunnels are unstable. And IPv6 doesn't like changing packet size. Don't tunnel. V6 in V4, bad idea. And as I've said and hammered at you, you should be able to recite this now. Keep the routing the same as much as possible. Don't let V6 wander off into the weeds because your customers will hate you. But there's one more thing, which is actually this strange intersection between software and hardware, which is actually causing us headache where there's no clear solution. V6 changed very few things, but it changed fragmentation. In V4, the fragmentation control fields were inside the header of the packet. And any router, if it couldn't forward the packet, was allowed to slice it into smaller segments and send these fragments on, and the endpoint at the other end would fix it all up, and you wouldn't even notice. So you could send a big packet, 1,500 octets or higher. And if there was a path in the middle that said, nah, I can't handle it, the router feeding that path would seamlessly fix everything up. Not in V6. V6 will not let you fragment on the fly, and routers will not do it. If you need to fragment, you do it way back at the source, and you add an extra header between IP and TCP. Now, I'm a switch, and these days switches don't just switch packets. Modern switches like to keep all the packets of one flow going down the same path. So even if you've got 5 output ports that will lead you to the same destination, you try and put all the packets from one TCP flow into one logical switching point. But how do you know how to do that? How do you know if a packet is a member of the same flow? That was a question. Someone can shout out an answer. You all lose. You have to look at the TCP header. Now in V4, the TCP header is precisely 20 octets past the head. So there's the packet start, there's TCP, that's where the port numbers lie. I'm there. What about V6? Well, it depends. Because if there's a header in the way, you have to unravel the header. Now, in a switch, you've got no memory and no time. No memory and no time. I just need to get rid of this packet. And I can't find the transport header. So what do you think a cheap cat switch does? A cheap Juniper switch does? A cheap Huawei switch does? The packet in V6 that has any kind of header. That was a question? Did someone say drop it? You win. Because the answer is drop. This is really, really bad. And I mean really bad. I mean that when we try and measure paths across the internet using the DNS, 38% of paths don't work. Because when we fragment the packet doesn't make it. Anyone who thinks you can run 1,500 octet MTUs in V6, you hate your customers. Because you can't fragment, that won't work. What about TCP? Oh, TCP is so much better. It's reduced the drop rate from 38% to 22%. I'm like, you can't go there. So V6 works well, but just don't fragment. So if you're running a dual stack service, keep your MTUs low. Google's Quick runs at 1340. That's a good number. not 1500. Because V6 does not handle fragmentation at all. And because of silicon, we're never going to fix it. We're never going to fix it. That drop will always happen. So the next big clue is V6 may have all these wonderful extension headers. On the public internet, you can't use them. Don't use them. All they do is cause your packets to drop. So that's the bad news. So what can we say? Well, overall, reliability is still not quite there. 2% drop is 2% too many. It should be as reliable as V4. Now, if you're an optimist, and I'm not really in the optimistic camp, I leave that to others. David over here is a dramatic optimist. He would expect that over time we'll just make this better. The problem for all of you is that customers won't complain because dual stack masks all the badness in 6. Because as long as you've got V4 to back you up, it's not a problem. It's not a problem. So with V6, I have to admit, for most of us in the engineering and ops world, you're lazy. Because you don't fix it, because you never notice it, because V6 cures all of those ills. So over time, things will get better. Frag headers won't, but over time, the rest of it will get better. So path MTU measurement, no. That is never going to change. That is just, you can't use extension headers in V6, don't kid yourself. So cleaning up the switching infrastructure, not an option. Not an option. So that's all I've got time for. Hopefully that gives you some insights. The big thing about this, keep your paths congruent, don't use complicated transition mechanisms, and keep your MTUs down. For God's sake, don't fragment. If you do all that, your customers will love you. Thank you.
Okay, thank you. Sorry, because of the time limit, we probably need to close all the Q&A section. But anyway, we shift the Q&A section to the coffee break. Please accept my apology. So before I introduce the next speaker, first I thank you, Jeff Houston, for his research finding. Usually when Jeff offers his research finding, the global ISP will rescope their IPv6 strategy. I hope that insight can help. Okay, the next speaker, I'd like to introduce Koji-san to give a talk on IPv6 deployment for the mobile network. Thank you.
Hello, everyone. My name is Koji from Japan. So I'm working for the SoftBank. SoftBank is no financial bank. It's kind of like a mobile phone company, the telecom companies, and we are providing an ISP as well. Today, I'd like to show you the IPv6 deployment for mobile networks because we have the experience to deploy the IPv6 for the mobile network. What is the next one? Oh, this one. Oh. My name is Koji. So I'm working for the SoftBank Corporation, which is a telecom company, and I'm joining the Internet Service Providers Association's mobile department. I know that in this session we don't have enough time, so I'm running to the quickly. So today, this slide shows why we started to migrate to the IPv6 world. So that's why it's commitment for the society and a commitment for the government. The 2015, we committed the 4 things. Number one is most important things is deploy IPv6 by 2018 March. So in Japan, we have 3 major mobile carriers. So SoftBank is one of them. So we formed the study groups with another carriers, and we studied lots of things for the migrate the IPv6. Firstly, the mobile company in Japan are thinking is what is the IPv6 world? That's it. It's kind of like the simple definition. It's like capability based. So customer use IPv6 naturally without the intention. So firstly, before the launching IPv6, of course, we don't provide IPv6, only we provide IPv4. But after the launching, we need to provide IPv6, but not only for the terminal. So we need to deploy IPv6 for our network as well. So after the commitment, the three major carriers formed the cross-study groups to share the situation and the issues and discussing the solutions. So this slide shows what should we do, what should we do is on our network. So on the cross-study group, we discuss a lot of things. We need to deploy the IPv6 whole section of this slide. For example, the UE means a terminal smartphone. This is the internet side. Of course, we need to apply the IPv6 capability for the user terminals, but we need to apply the IPv6 capability for the whole sections of our network side. Of course, internet is already IPv6. So especially the terminal, these are difficult things because we need to order the terminal companies, handset manufacturer. So how is the appropriate spec? How should we do the testing for the IPv6 capability? Because sometimes we need to, the customer roaming out, that's the quite big differences with the fixed network. And antenna is not big issue, but so particularly we face the big issues on the core network side and the information systems, particularly the billing. This is the basic scenario to deploy the IPv6 for the customers. We have two scenarios here. One is here. So we'd like to show you the first scenario is, this is the current customer before launching IPv6. Of course, the customer's handset use IPv4 and our core network use IPv4. New customers coming, we deploy IPv6 network for core network here, and customer get IPv6 capable handset. In this scenario, of course, the current customer cannot use the IPv6 forever. But fortunately, the mobile situation is quite different with the fixed line, because customer change the handset often, every 3 years, 2 years, something. So gradually, customer you change to the new handset. It's like a moderate changing, migrating. This is one of the scenario. Next one is, basically, it's same with the scenario one, but the scenario one has an issue. If a customer use the handset a long time, customer still using the IPv4. So in this scenario, firstly we migrate our core network to IPv6, and on remotes, we change the customer's handset's configuration and to connect the IPv6 network. Anyway, so the previous slides, we can understand the network capability, network capacity is one of the restrictions for the IPv6 migration. The core network capacity is increasing, but not at once. On the network capacity, the all equipment, all handset, which are sold by the mobile carrier, adopt each. We need to decide which network should belong. So, for example, at the point here, network capacity is here. If mobile carriers sell the 300 set, but only 200 set should be capable for IPv6 to connect IPv6. Unfortunately, one of model cannot connect IPv6, only by IPv4 means. That's a kind of like a moderate the migration scenario. But actually the Japanese major carriers adopt this migration scenario because the previous slide, this migration has the risk because we cannot handle every customer's environment, every customer's handset situation. Of course, we can change the setting, customer setting, but we don't know what's happening, what's going on after the changing the setting. And I'd like to show you another risk when we discussed. That's a normal procedure for the assignment IPv6, sorry. If your mobile phone handset, you powered on your handset making a touch procedure with the mobile network. This is like a kind of like a radio networks procedures. After that, the handset send the request to the network to assign the IPv6, IPv4. On this scenario, the handset send the PDP context request with IPv4, IPv6 as a dual stack. Of course, the three major carriers, Japanese carriers, prepared IPv6 capability already. So, but another foreigners carriers, when customers roaming out, maybe a carrier doesn't have the capability of IPv6 or something. Roaming network replied to customers, hey, we don't have our IPv6 capability. You need to send us IPv4 request again. So if in this situation, the handset understand, oh, okay, so your network have a capability of IPv4 only, so okay, I will send IPv4 request. That's a normal procedure. Of course, these procedures should be successful, and after these procedures, the handset can connect to the internet normally. But this is failure procedures. So we cannot manage, of course, we cannot manage any other foreigners roaming out carriers equipment. If, oh, yes, that's what, handset requests the same things to acquire the IPv4 and IPv6. After that, if roaming network reply the different code as a normal, it's mean the unknown by the handset. Handset cannot understand what's going on, and handset retry to send the IPv4, IPv6 request. Of course, roaming network reply to terminal with an unknown code. That's a looping. So in this situation, handset cannot connect to the internet, cannot connect to the mobile network as IP network. Of course, the handset can connect to their own core, but cannot connect to the IP network. That's the risk we discussed it. Actually, we did not have any solution about that situation, so currently we provide IPv6 for the every customers, but we don't provide IPv6 on the roaming network. Through these discussion, we have launched the IPv6 for other three major carriers. For firstly, SoftBank launched the IPv6 the 2016, and NTT Docomo and KDDI as well, we launched it. It's free. Now, it's not big, but we disclose the IPv6 penetration ratio every 6 months, and currently calculated 28.9% of as an IPv6 penetration ratio. It's a bunch of these three carriers. Of course, these numbers are calculated by the network capacity and enabled UEs. So if every handset is capable for IPv6, but network is not capable, these numbers should be going down. This slide shows it's good things to migrate IPv6 because so usually we provide the portals website, portal services, or something internal services for the customers directly. Before launching IPv6, we have some network with IPv4, 10.0.0.0/8 or something. Of course, IPv4 has a restriction of the network size, so we need to have the fragmented network. So we need to make each networks and each authentications is proxies as well. But after the launching IPv6, we are thinking is migrate as a service network. That's going to be easy to manage the customers and billing as well. This slide is the last slide for me. So we can see what is the good things, what is the benefit, and what is the no good things for the carriers. This is short, middle term. This is long term. Pros, cons. On the short term, we have to pay a lot to migrate IPv6. Actually, we paid for the migrating CDR billing systems. Of course, we need to invest for network facilities, and especially we need to prepare the human resources for the network operational and administration. And investigation operation is so if the court decide to disclose the customer's information, so we need to find the customer's information that we need to disclose that. But so the IPv4, we can search only the IPv4 CDR, but so on the dual stack world, we need to search both. short term, so we have some investment and cost, but on the long term, we have some benefit on network. Because so, as I showed you, IPv6 network should be simplified, so we can simplify the facility operations and traffic management too. And another side here, trigger of IPv6 migration for CSPs. So now we done to migrate the IPv6. For the next step, the content service provider are discussing for the IPv6 world. That's on my slide. Thank you so much.
Okay, thank you, Koji-san. I'd like to invite the next speaker, a new hand from Vietnam, to introduce IPv6 deployment in Vietnam. Okay, thank you.
Good morning, everyone. My name is Thang. I'm Deputy DG of IPNIC. You are a standing member of Vietnam IPv6 Task Force. So my presentation today is the story about Vietnamese and IPv6 deployment. Because the time is short, so I prepare my presentation very short, about 10 slides. And I'm not going to talk about the technical. So just an update about how we promote the V6 deployment in Vietnam and share our experiment, how to promote the community adopt V6 quickly. So my content of presentation is around 5 questions. This is a simple question you can see on the screen. So start with the first question is when we start with V6, we start V6 very early, about 20 years ago. But in 10 years ago, we officially start the Vietnam National IPv6 Task Force, and VNIC is a standing member of that task force, and we draft the National Action Plan for IPv6 adoption. Detail about 8-year plan from 2011 to 2019. So now this year is the last year of our National Action Plan. We finish this action plan in a few months. So why we adopt a V6 so early? That is very simple, as you understand, because we are in the AP region and we are don't have enough IPv4 for internet development in Vietnam. We want to provide the fiber to the home for every subscriber at the home, about 100 million citizens in Vietnam. And we plan to adopt the 4G and 5G for the citizens in Vietnam. And because follow the change, the international standard, IAB Internet Architect Board already announced 2 years ago that we stop to develop the V4 protocol and they focus on V6. So as a country already go with V6, so we want to go together with the other country. So that's why we moved to V6. So the reason is not only the IPv6 exhausted, the main reason is for the future. So where we are now, so we, at the June this year, we are in the 5th position in the world about IPv6 capable, as you see on the screen. And the two, Vietnam and Malaysia, are on the racing to keep the number 1 position in the ASEAN country. So you can see on the table on the left screen You see, we start to adopt V6 in real network from 2016 and grow rate very high in the recent year. So how we promote the V6 and get a little bit successful in IPv6 promotion in Vietnam, because we have a Vietnam IPv6 task force work very actively. The role of IPv6 task force is leading and promoting and supporting and collaboration with the community to work together to deploy the V6 in Vietnam. And the first thing we do is prepare the policy to require adopt IPv6 at the government sector, the public sector, because the government in Vietnam and I think in other countries all the way slower than private sector. So we need the law, the decree and circular to require all the government agency to support to do with V6 when they buy the new equipment. They must buy the IPv6 compatible equipment. We do not accept the V4 equipment when they buy or do bidding. And you have some recommendation and official letter from Minister of Information and Communication to require all the government agency to adopt V6. And we do a lot of training for the people in Vietnam. We do the training for ISP, so for mobile operator, and for content provider, and for software company, and also so for government agency. So now we have already trained about near 2,108 student people have been trained with V6, and we have a different training course for different people. For example, we start with the basic training course for V6 and put on each online, and everybody can access our website and learn online about basic about V6. And we have another course for software developer, the course for IoT, the training course for 4G, and training course for government network. And communication is so important when we already keep the people up to date with the V6 deployment and give them up-to-date information about the information relating to IPv6 adoption around the world and country in ASEAN country. And we give them some guidelines step by step to adopt V6. And we have a conference, we have an annual Vietnam National IPv6 Day every year. And workshop before that, we have a support from APNIC and ISOC and other organizations to do some workshop for the community. So we have a V6 presentation at a lot of ICT events in Vietnam to give the people have a awareness about V6. And the task force also come to the office of government office and some selected company to work together with them and give them some consulting to help them to move to V6 more quickly. So it's a key point help us to finish our task. I think there's some key point here you can share with you. The first is to give the people have a motivation to adopt the V6, because some people said that we have still have enough V4 pool. We don't need to move to V6 so early. So we told that we don't agree about that. I wish for exhausted already, but it's not main reason to move to V6. The main reason to V6 is V6 for future, and to prepare for the future, we need long time. So we must start very soon, and we give them not awareness, give them the passion about V6 adoption. And we give them the competition between the small and big company and give them a passion and mission. And who we start first, we don't start with big company or big government agency first. We do with small or medium company and small local government first, because you know that every big company or big government agency always low and not easy to require them to adopt V6. So we start with small and big, and our formula is start with small and to kick the big, give them the competition. And with the government agency, we not only promote them, we require them to adopt the V6, because the government, if we don't have any requirement, government always go very slow. So we have a policy to require the own government agency to adopt the V6. Another key point is we work together with the ISP and mobile operator and government agency to help them to understand the V6, to understand how to move to V6 step by step. The last one is we have a two IPv6 launching in Vietnam. It's a little bit different with the other country in the world. So the first launching in 2013. So the first launching, we focus on the ISP and some pioneer from government, some pioneer from content provider, some big content provider. They want to launch IPv6 first. So we have a first launching 6 years ago. So that few months ago, we have another IPv6 launching for cloud service provider, internet data center, and government agency. So you see on screen, we have a two launching to promote the people, to keep the people the passion to adopt the V6. This is a key point, help us to promote V6 in Vietnam. So what's next? First, we will finish our national action plan on V6 at the end of this year. And for the future, there are a lot of things we need to do in the future. The first, I think, is make the IPv6 network in Vietnam more stable, reduce the failure ratio below the 2 or 3%, and we must focus on the next 5 years is move content provider to adopt the V6, and government agency to adopt V6, and some 5G and IoT network not turn on with V6. You know that in next year, the car racing for Formula 1 will be organized in Vietnam. So government and some big telco have planned to provide a 5G network around the racing stadium with 5G and V6. So the people, when they come to Formula 1 racing stadium, they can enjoy the 5G network with V6 in Vietnam in next month. For government agency, we have a special program. This is a guideline for government agency we prepare already and provide for them. This include 3 steps and 10 steps. They help them to do step by step. Sorry, it's in Vietnamese. So that is we do for government. It's a focus thing we must do in the next few years. Yeah, that's all for my presentation today. Thank you.
Thank you. The last speaker, shall I invite Mai Lei, going to introduce Ireland in the IPv6 world. Thank you.
Thank you for the introduction. Time is very short. It's a good thing I literally put every word I should say in the presentation, so if you can refer to it later, but I'll just pick a few things along the way. That's my title, Island in the IPv6 world. And yeah, that's the map for the APNIC adoption. I just visited yesterday. There is nowhere you can find Tonga there, somewhere. But I like this version. It's the table format of the same map. It's on the third place. I'm not sure whether, but I think it's there because we did. It shows that we done some work on IPv6 adoption in our place. A few slides coming is just how was our our plan and how and our plan to adopt the IPv6. And these details you can refer to it if you are interested. It will relate to some of you from our point of view, like smaller islands like us, or even ISPs. There's a bit of history and what has changed over the years. Actually, what has changed for us, it was from APNIC48 in New Caledonia. We just noticed that everything is ready. Our devices is ready, our CPE is ready, everything is ready. It's just us to enable the V6. So those are the slides about. There's the Facebook measurement adoption, nothing. There's 0 point there. Tonga, the Google map, still nothing. And from there, it just put something we can. Maybe we can put, if we can enable V6, and we can put some funny stuff like this, as the Facebook does. There's a domain tcc.to, just for fun. Can we do it? Yes. That's the main thing here is, from a point of view from a smaller island nation, we can deploy it. It's no longer, we are in the remote corner of the world without awareness of the IPv6. IPv6 is there, it can be done. We are lucky that there comes the fiber project. Along the way, we did domestic fiber to other island, which help us centralize everything, which makes it easy for the deployment. And there comes our development plan in these steps. We did the audit and the plan a few years back, and we just did the review after APNIC48. We reviewed the network infrastructure. We noticed that the LTP for MPLS does not support V6, but it does support, the devices support the 6 VPE, which can carry the V6 prefix. And our adoption is dual stack, to our broadband at least. Also, we continue to our CPE, Windows, the modems we use for our broadband, Linux server for resolver, they are all supported V6. All we need to do is just adjust our PPOE 1 setting. That's our actual deployment configuration. I won't go into detail. I'll just highlight a few things. The red stuff is our address planning. I'm sure what I'm trying to say here is I did not put it up on the presentation because I think the case for us, it won't work for you guys. So, but you are feel free if you can ask, we can discuss it sometimes later. The configurations, the layer 2 switches for our MSN every layer 2 network readily support the header for V6. Our configuration for our PRSs, those are the next few slides are the actual configuration we use. I just put it there. I'm sure it might help someone like us. The more interesting thing I shall forward into is the testing. And a few stories about our APGP for V6. Actually, our upstream is Findel. At first, their upstream A do not support V6, but once we enable that, we find out that we can't connect to Google. And then we know that they have another V4 peer with option B, so we ask them again for that V6 on that leg. And finally, we access to V6 content on that upstream of our upstream. Test cases, we did a few test cases to some Google file, also download video, and also Facebook video. For the test cases we use a network alarm behind a firewall. I mentioned here because a normal V4 traffic, it's on net 4.4, and the V6, it's just straight to the internet. Here are a few things we can have a look at. This is a V4 connection. I use this app on GUI traceroute. I just want to see how our packets travel on the internet. Let's go to Tonga for this particular test, to Tonga, to Fiji, to United States, and the content is there. And on V6 is a different path. It goes to Tonga, to Fiji, to New Zealand, United States, come back to Australia. I don't know why it's said, but that's how things work back at home. And you view the next slide. I want to highlight there's another test for the Facebook, another video. Those graphs are the I/O graph from the Wireshark. I'm sure you're already aware of it. You can run your download and run the graph at the same time. Compare the V4 to V6. V6 looks much smoother. There's the finding from video test we did. Not the V4, it goes all the way to Spain, then come back to New Zealand. We don't know why is that, but that's what we find out. Also, a video we test another video for Facebook. Again, we find some interesting stuff there. V4, it goes to Canada for some reason. See the throughput for that particular download, it makes at 1.27 Mbps. For V6, it's different. It also goes all the way to Canada, but you see the download time is it's half. It's more than half of that of V4. What you get out of this, I think it's our location and some content far away from us. V6 is our better choice than V4. So it's a good point to ask the management to deploy it. Faster you download that much of content, meaning the customer will pay a bit of more money in that amount of time using on V4. This is a test I did on the way here in New Zealand. The content that is close to you won't see any difference. It's literally the same. The graph to the left, that's your window size bytes, again from TCP Wireshark stream, and on to the right, that's your I/O graph. It's literally just shows the same result. That's a graph from the previous slide. Some final thoughts, as I said, for our mobile network, it will be a long story because there are a lot of things we'll be taking account, given that our vendor and all those. But for our case, for our broadband, it's pretty straightforward to do it. So that's what we're going to do. Within the 1 month or 2, we will be mass deployed on our broadband. This is the current trend on our traffic. The graph to the right, that's our total traffic. If you note, it's only 2 GB at maximum. The left, that's our current IPv6 traffic. It's only up to 104 Mbps. Within the month or 2, we will mass deploy it on our broadband network. I'm sure that will be a lot more higher than that in a few months. So I think that's all. That's all I can say. There are a few words of thanks for APNIC Foundation, and everyone for I hope you enjoy.
Okay, right, thank you. I must apologize again because I don't have sufficient time for you for running the Q&A section. But But however, please feel free to approach the speaker nearby during the coffee break if you have any question. Okay, before I adjourn the section, can we give a big hand to all speakers here? Okay, the session closed. Coffee break is served outside. Thank you.